Okay, so welcome to the class, and what we have been discussing is this codebook based MIMO. Okay, and we will continue discussing this today. In this class we'll wrap it up. So what we learned yesterday was that how codebooks are used to feed back the channel information for NL is equal to 1 layer, okay, wherein base station had 2 antennas and then UE had 1 antenna, okay. Right, and then what we are going to see today is how does this happen for NL greater than 2 layers, okay, greater than equal to 2 layers. We will take an example of NL is equal to 2 layers, and then we will see what additional information UE needs to feed back when the number of layers is greater than 1. How does this happen? And then the additional information, okay. So we will quickly recapture what we learned here, and then we will move on to this aspect, okay. So what we saw here was that we considered this example case wherein the base station has 2 antennas. We are looking at the downlink, okay. User has 1 antenna, so the rank of the system is 1, right? It doesn't matter how many our antennas base station has, okay. We are taking example of 2 antennas, but the same idea is applicable for any number of antennas, okay. What have I given you is code book for 2 antennas, okay. If there are more number of antennas, the code book will accordingly have to be different, okay, and these code books are defined in the standard, okay, for different number of antennas. So the idea is readily extendable to any number of antennas at the base station, but the UE only has 1 antenna, okay, right. So this is the example code book which we saw, and what we saw here was in this code book is giving information only about the phase of the channel, right, okay. So because it does not, the way this code book is designed, all these channels, if you look at it, okay, both of them have the unit magnitude in all these code book entries, okay, and what is different across these code book entries is only the phase, okay. And what this code book helps us in feeding back is indirectly the channel information, okay, right. And why it is indirect? Because as we saw yesterday, that UE picks up the code book which maximizes SINR, okay, and which precoder entry this code book will be used as the precoder at the base station, okay, right. And UE picks up this entry such that it maximizes the SNR, okay, and we know which precoder maximizes the SNR for this kind of system, okay. It is maximum ratio transmission, okay. So in practice, what is UE doing? It is UE has estimated the channel, okay. Instead of directly indicating what is the channel, it tells the base station, please use this precoder so that my SNR gets maximized, correct, and which is basically indirectly telling the channel, and but there is a clear limitation on the way this channel is being indicated, and there is only the channel information has to be indicated only using 2 bits, right, because UE can indicate only one of these entries and it needs only 2 bits to do that, okay, right. So if you need to send more information, basically if the code book size is bigger, then you need more bits, and those code books are also defined in the standard, okay, and those code books are typically used for multi-user MIMO, okay. And I have not taught you that, but the feedback required for sending those bigger size code book is much more than the simple example which we are taking now, okay, right. So and feedback runs into hundreds of bits, okay. You see only 2 bits. This feedback runs into hundreds of bits for different kind of code books, okay, and that is, as I said, for multi-user MIMO. So now what does this code book contain? It contains only 4 precoders, okay, as I said, these 4 precoders, and UE will choose the precoder entry which maximizes the SNR of I. And how did we define this SNR of I? That is defined in the next slide, okay. And how is this calculated? UE assumes that base station is using the precoder V of I, because that's what it is indicating, okay. It assumes this is a system model, okay, right. If whatever precoder entry it will feed back, base station is going to use that entry as the precoder, okay. So it knows the system, okay, that the base station has, because because if base station has 2 antennas, because it is picking out the entry from 2 antenna code book, right? And it has estimated, user has estimated these 2 channels only, and they are unprecoded channels, right? So all this information is not hidden from the user, that how many antennas base station is using to transmit the signal in this case, right? Okay, correct. So what UE assumes is that G node B is using this precoder, and G node B will transmit. If it is using this precoder, what will G node B do? Precoder, what is the first entry of the precoder? VI1. That's okay. So what will be sent from first antenna? VI1 into X, if X is the transmit signal, because you will transmit only one symbol, it is a layer 1 transmission. Okay, right? And so G node B will transmit this from first antenna, and this is from, it will transmit this from the second antenna. Okay, because this is a second entry multiplied by the symbol. Okay, right? You remember this, where this is coming from. Okay, what happens? VI1 right? This is what is being transmitted, and so this is from first antenna, this is from second antenna, and the received signal is this thing, correct? This is the signal from first antenna gets multiplied with the channel from first antenna, similarly from second antenna, and the noise, right? And so this is what user is assuming, that's what it is, that's how the signal will be transmitted, and it knows this channel, okay? And what it needs for calculating the SNR is basically the power of X, right? And then what it does is, it knows all the precoder entries, okay, HVI, VI it knows, and what it does is it calculates the SNR like this. Whichever precoder entry maximizes the SNR, it feeds back that precoder entry to the base station, okay? And this information is called PMI, okay, precoder matrix indication, okay? And you see this is because UE has one antenna, and then it implicitly knows that the rank of the channel is 1, right? And if it has 2 antennas, you will see that I am going to discuss that it will have to feed back something called rank information also, okay? So along with precoder matrix indication, it feeds back RI, this is called rank information. I will tell you how all that is done. So we will have to extend that system model, right? Because in this case it is a simple model wherein the rank is 1, precoder matrix indication is whatever is out of those 4 entries, okay, right? So now from the last slide to this slide, where are we moving? What we are saying here is, this is for a single antenna system. Now let's say I want to extend it to a generic case wherein transmitter has multiple antennas and user has also multiple antennas, receiver also has multiple antennas, and we know this system, we have looked at it multiple times, okay, right? So, and we looked at it in context of TDD system, wherein the base station knows the channel and it can design the precoder, correct, okay? And this is, base station uses precoder V, NL layers, precoder maps this to the NT antennas, goes through a channel, multiplied, the received signal gets multiplied by W of H, and NL layers are basically recovered at the receiver, okay? So it is a generic framework which can help us in transmitting NL data layers or streams, okay, right? And what happens if NR is set to 1, it reduces to the framework on the last slide, because number of receiver antenna is 1, okay, fine, okay. Now how does this work? Then we write it again mathematically. What happens here? So mathematical model for this NR cross NT system with how many layers? This is the number of layer, okay. What is the system model? What is this? H, X tilde. X tilde is the precoded signal, which is V. X tilde is the precoded signal, and what have I done? I have just written H as W lambda V Hermitian, okay, SVD. And then what happens here? I pick the precoder as some M, okay, I am not writing it as V because base station doesn't know that, right, okay. So this precoder base station should find out what is the precoder, and who is going to feed back this information? User, correct, okay, right, and W lambda V Hermitian, and if it finds out that this is the base user feeds back this information, okay, then the precoder M becomes V. Okay, I am not directly writing it, I am saying that the user has to feed back this information, and user will have to calculate this V and then feed it back to the base station. Then base station is going to use this precoder. Okay, right? That's why this two-step process. And then, correct, if then base station later, if base station uses this precoder, okay, then what will happen? User will use a particular receiver, and if in this case everything is fine, it knows that channel is stationary, nothing has changed, it will design this receiver. Receiver will be W Hermitian and will be able to recover lambda of x. It's a diagonal system. Okay, if you look at y tilde, all the streams are decoupled together. Okay, and you'll be able to recover the data. Okay, but the clear problem what we are looking at is how base station find out what precoder M to use. Correct, because it does not have the channel information, only user has the channel information. Correct. Okay, so if it is a NT cross NR system or NR cross NT system, what happens? Base station will first transmit NT port CSIRS, right? Okay, because user has to estimate the channel, and what is the channel dimension? NR cross NT, right? It is the unprecoded channel. Okay, correct. And then in order to estimate this complete channel, these many ports of CSIRS should be transmitted. Let's say that has happened. Okay, it is assumed that base user has estimated the channel. Okay, and after that, what happens? Okay, user has the channel information, right? How does it design this precoder? What is the code book? And then the next step of estimating the rank. Okay, how does that happen? That's what we are going to look at. Okay, fine. So for G node B to use this precoder, UE has to either feed back H or V, right? Either feeds back this H or feed back this V. Okay, and we know now that it will never feed H. Okay, it will feed back V. Okay, and that feedback, and then this V will be one of some code book entries, right? Okay, we saw that. Okay, for a simple system. Now we are doing it for some other system wherein the rank is not 1. Okay, and we are going to do it for rank 2 system. Okay, right. So, but the same ideas will be applicable for higher rank system also. Okay, so what are we saying here? It will neither feedback H, okay, nor feedback V also directly. It will feedback some of the code book entries which are defined, which are known both to the base station and the user. Okay, right. So now what are we saying here? So I'm looking at a very specific case, again simplifying the system, and if you understand what is happening here, they are applicable for any generic NR cross NT system. What is this? What are we considering here? I'm considering a 2 cross 2 system. Okay, 2 transmit, 2 receive. Okay, so you see this is a code book. I'm taking a simple example. This is how, I've simplified it because if you look at 5G, the number of base station antennas is 64. So I've reduced the system, okay, for us to understand what is happening. Okay, correct. So this is 2 transmit antenna code book. Okay, only 2 entries, so 1 bit feedback. Fine. Okay, one of these entries need to be transmitted back to the base station by the user. Okay, and what user has done is it has estimated the channel H. Okay, fine, right? So what will it do? Okay, so first thing you notice is rank 2 codebook has only 2 precoders when compared with 4 of rank 1. Okay, so this is, I've simplified it. And now, so the system model for this codebook based MIMO, what we are doing, okay, this is called spatial multiplexing also because you're multiplexing multiple streams in parallel. Okay, just for the record. Okay, so what is this is our system, right? Okay, y is equal to hx tilde plus n. Okay, then user assumes that one of these precoder entry is transmitted. Okay, something similar to what we did in the last case. Okay, vi. Okay, user has the channel information, right? So what will happen? I call this as h tilde of I, hv of I. What is I? Either of these codebook entries, correct? Okay, right? And then I call this h tilde of I, and then you'll have to design some receiver, correct? Because what is happening here? This is one thing which is different from rank 1 case. Okay, you look at this, 2 layers are being transmitted. Okay, these 2 layers need to be separated. Right, then the receiver needs to be designed by the user. Okay, so there is some receiver W which user is designing. It can be SVD based, it can be zero forcing, it can be any MMSC based receiver. Okay, that is being done, and once that is done, right? What happens? Okay, so this is the equivalent system. WH of y, it becomes, what is this? We can call this as y tilde. Okay, I'm not, right? So this is a vector. Okay, and user looks at this vector. So we are assuming that once this receiver design is done, user does this operation, all these two streams are decoupled together, or these two layers are decoupled together, right? Okay, fine. Then what does it do? Okay, so now there are two entries. Okay, what will it do? So it has to design. What are we saying here? It has to decide which precoder information should be fed back, right? Okay, how is it going to do? To select this particular precoder V of I, UE does the following. Okay, for both of these entries, right, I will run from 1 and 2. There are two precoder entries. Okay, for each one of them, right, because it doesn't know what is the best entry, so it has to run this operation for both of them. Correct? Okay, so it does, what it does is, it does HV1. Okay, designs a receiver W for that. Correct? Okay, right? I call it Wi. Okay, and what is this HI tilde? This is right. Okay, so step number 1, precoder 1, you calculate H1 tilde, design W1 for that. Okay, it can be any receiver based on what UE's capabilities are. Okay, it can be like MMSC receiver, it can be SVD receiver, it can be zero forcing receiver, any receiver. Okay, but the receiver design will be different for H1 tilde and H2 tilde. Why? Because in one case you are multiplying H with V1, in another case you are multiplying H with V2, right? So the matrix become different, the inverses will be different, that's what I am saying. If you are using zero forcing receiver, inverse of H1 tilde is different from inverse of H2 tilde. Correct? Okay, so this step has to be done for both these precoders. Okay, right? So idea is clear. Okay, H is estimated, then HV1 tilde is H1 tilde is calculated. Okay, and W1 is calculated. Then this operation is done. Right? These two streams are decoupled now for precoder V1. Similarly, you have to do it for precoder V2 as well. Right? Okay. So once this is done, what happens? Okay, that what will user do after that? Okay, this is the first step. Okay, now second step will be, see, these two streams are decoupled together. Okay, right? What will it find out? In this case, okay, in the last case it found out SNR. There was only one layer. Okay, and in this case it will find out SINR, signal to interference plus noise ratio. Okay, right? What will it find out? In each case, let's say it does this operation for H1 tilde. Okay, how many layers are there? 2. Correct? Each layer, first layer. Okay, look at this. What am I saying here? SINR I1. Okay, SINR when the precoder entry is 1, of which layer? Layer 1. Correct? Okay, what will be the SINR? P is there because X is by N0. And what am I writing over here? Some function of the channel. Okay, that because if you do zero forcing, correct, the signal will not have any channel term, but the noise will have. Right? H inverse will multiply the noise. Correct? So it will be SINR will be some function of the channel, of course. Okay, we don't know what it will be based on the receiver design. So this is something you can say that, because if we do the SVD, what will come here? Singular values. You remember lambda 1 square P by N0, lambda 2 square P by N0. If it is zero forcing, those lambdas will be different. Okay, because those coefficients will be different because you have done a different receiver design. Right? Okay. So SINR is a function of receiver design plus the precoder also, because what are you doing? You are looking at a H tilde, H1 tilde, H2 tilde. Right? Okay. So what has happened? It is looking at precoder I, calculating the SINR of first layer, calculating the SINR of second layer, right? Okay, and what it does is computes the sum rate. Okay, right? Because what is user interested in? Okay, it is interested in maximizing the rate, log 1 plus SINR, right? You remember in the last case, what did we maximize? SNR. That was indirectly saying that it is maximizing the rate because there was only one layer, log 1 plus SNR, right? Okay. Here what am I saying here is that this is SINR, okay. There are two streams, each of the stream will have a different rate, okay, correct. So what it does is it calculates the rate of first stream, it calculates the rate of second stream for each of this precoder I, right, and calculate the sum rate. Look at the index, it is SRI, because you are calculating for a particular precoder I. So you will calculate this for, you will have two such numbers of sum rate, okay, for each of this precoder, right. It will become sum rate 1 and sum rate 2. What happens after that? Feed back the index of precoder matrix Vi with which maximizes the sum rate SRI. Two numbers, whichever is greater, is basically if, right, you will feed back that precoder index. Correct. V1 maximizes the sum rate. You tell the base station that please use this precoder for me. It is maximizing my sum rate, right? Okay. Similarly here, okay, whatever precoder entry maximizes the sum rate, that is fed back by the user to the base station, right? Okay. So this step, you should remember these two steps. These steps are done before data is transmitted, because what are we doing? Okay, that look at the flow of the system. Okay, it is a FDD system or even TDD system wherein base station does not have the downlink channel information, right? It wants to precode the signal. It is asking the user to feed back that information back to the base station. Okay, so data has not been transmitted. Correct? Okay, so this is only the precoder calculation stage, and it is done when CSIRS is transmitted. Okay, and why will CSIRS be transmitted? Because base station wants to find out the precoder information, right? And in this case, in whatever we have learned, the CSIRS which is being transmitted is unprecoded CSIRS. Correct? Right? Okay. And in fact, if you look at it, then so this is sum rate. Okay. Now, during this step, if this is the sum rate, user can feed back the MCS information also. Right? What is the MCS information? Rate only, right? Okay. So it will feed back PMI, it will feed back MCS. Correct? Because what is MCS? This sum rate which is being observed. Now you look at it, if there is the way I have taught you or the way it is done in the standard, right? How many MCS indices user will feed back in this case? Only one, because only one transport block is sent from the MAC to the physical layer when the rank is less than or equal to 4. Right? Okay, correct. So, and that MCS information will correspond to this particular rate. Right? Okay, so fine. Okay, so PMI and MCS. Okay, so is this clear? Okay, how this is done? And please remember that this channel information is fed back indirectly, right? And base station is also not interested in finding out the channel. It is interested in finding out what precoder it should use. And if UE tells that use this precoder, it doesn't care about the channel after that. Why should it? It needs the channel information to, as I said, to calculate the precoder. Right? Okay. So raw channel, as I said, is never fed back by the user to the base station. It is only one of the precoder information is sent, and that too also through codebook entries, which are known both to the base station and to the user. Right? Okay. Fine. There is one more thing left, and that is the rank information. Okay. Because if you remember, okay, so that is in this slide. We will discuss about this idea of rank calculation, okay, and then in the next class we will look at all in details how this happens. Okay. So what is this rank? We are looking at a channel H, right? For the system which we considered earlier, okay, transmitter has 2 antennas, receiver has 2 antennas. Okay. So it is what is the channel metric? What is the dimension of the channel metric? 2 cross 2, right? Now what is the maximum rank of a 2 cross 2 matrix? 2. What is the minimum rank of a 2 cross 2 matrix? 1. Right? Okay. Because if two columns of this channel are dependent on each other, what happens? The rank becomes 1. This is basic fundamental linear algebra, okay, right? That rank can be 1 or 2, okay, and the rank of such a matrix is 2 if two columns are linearly independent of each other. Rank of this matrix is 1 if the columns are dependent on each other, right? Now I am bringing this notion for the first time that this rank can be 1 or 2, okay, and it could happen in practice also, right? That user is observing a channel whose rank, even though transmitter has 2 antennas and receiver has 2 antennas, it is not guaranteed that the rank will always be 2. Okay? Because the channel could be such that, that these two columns are dependent on each other. It could happen. Okay? Right? How can it happen? I am not going to discuss that in detail here. Okay? We don't have time. But the rank can be 1 or 2. That's the problem. Okay? Right? If the rank can be 1 or 2, user needs to find out that also. Okay? Because user only has the channel information. Okay? If the rank is 1, then it will be how many layers user base station can transmit? Only 1. If the rank is 2, it can transmit 2 layers. Right? Okay? Fine. And UE will feed back that information also back to the base station. So in the control information which is fed back, as I said, user has to feed back RI also. Okay, so that's the problem. Okay, that channel rank is 2, but the channel rank can also be 1. This is the maximum, minimum is 1. Fine. Okay, we are bringing in this notion for the first time because we have to discuss about rank information. Till now we have always been saying that the rank is 2 if it is a 2 cross 2 system. Okay, we did not have to focus on this rank 1 because there is no point in doing that, but rank can also be 1, and that's what we are going to see. So this rank has to be indicated to the G node B by the user, okay, because user only has the channel information. Okay, so this parameter is called rank indicator. Okay, right? And how will a UE decide which rank to indicate? Correct? Okay, there should be some recipe. Again, that comes from, I'll teach you very basic principles. Okay, if you have understood what has happened on the last slide, how to calculate the sum rate, okay, this rank calculation recipe will also be easy to understand. Okay, so we'll next discuss an algorithm that UE can employ to calculate the rank. Okay, the recipe I'll give you for this system. Okay, how to calculate the rank. Okay, then what will happen with this information is that UE feedback, UE has to feed back. What will it feed back? It will feed back RI, it will feed back PMI, it will feed back MCS to the G node B. Okay, right? If it is so, this always needs to be fed back because the way 5G or 4G systems were designed, base station always has multiple antennas. Okay, correct? So whenever the control information is sent, right, by the user to the base station, these 3 parameters will always be sent by the user because there is always a MIMO transmission. Number of layer could be 1, right? Okay, because base station is deploying 64 tens of antennas, correct? Okay, right? So if this is the case which we are discussing, wherein base station does not have the channel information, okay, user will always have to feed back 3 parameters, not only MCS. Right? Because without these 2 parameters, base station cannot precode the signal. And we know without precoding the signal, those multiple antennas at the base station, okay, serve very limited purpose. Okay, right? So this is always done. Correct? Okay. So we will, in the next class, we'll immediately begin with discussing this rank indicator recipe. Okay, it's very simple. Okay. But before we discuss that and to conclude this class, what have we learned in this class? What we have seen here is that we have extended the idea of UE feeding back this precoder information from NL is equal to 1 layer to NL is equal to 2 layers. Okay, right? And if if it is for NL is equal to 3 layer, what will happen? Same idea, right? Okay, so it will be, let's say it's a 3 cross 3 system or 4 cross 3 system or 64 cross 3 system, correct? User will have the complete channel information through the CSIRS, right? Okay, and it knows that UE knows that it has 3 antennas. Okay, so what will it do? Right, there will be a different code book, not this code book. There will be a different code book which is defined for this system, correct? Okay, it will do all these operations whatever we did in the last slide. Okay, so it will calculate basically depending on how many entries that code book has. Okay, let's go back just to how many entries code book has, right? Okay, it will feed back. Instead of 1 or 2, it will feed back. Let's say there are like 16 entries in the code book for a higher dimension system. You will have to do this operation, right, for all 16 entries of the code book, correct? And then if it is a rank 3 system, right, it will have to do, so it will figure out how many such sum rates will be there. There will be 16 different sum rates corresponding to 16 different entries of the code book, right? And how will that sum rate, these sum rate be calculated? Because maximum rank is 3, we are assuming that, okay? I1, I2 and I3, sum all of them for 16 different code book entries, okay? Whichever code book entry gives you the maximum, you feed it back to the base station, right? Okay, so the idea remains same. Estimate the channel, right? Design the receiver for each of this precoder entry, calculate the SINR of 3 layers, sum them. There will be 16 different entries, 16 different sum rates corresponding to 16 different entries of the code book, feed back the maximum. That's all. Okay, so we stop here. Thank you.